Hi everyone, and welcome back to another video of IGCSE Math Preparation Series. My name is Erfan, and today we're going to talk about set notation and Venn diagrams. So the first thing that we need to take care of is, what is a set? Well, set is nothing but a bunch of objects or numbers or symbols or even names that are well defined. So I have listed, I have written a few samples on the board. As you can see, I have defined set A. So I have called it A, and make sure you put the elements of your set. So each elements belongs to, these are called elements, right? Elements of set A, you should put it in a curly bracket. So this is a set which has 4 members or 4 elements, and they are integers, the 1, 2, 3, 4, or you can say the first 4 whole numbers, right? That's another way you can define it. And set B is basically all the x's such that x is greater than 2. We assume that x is a real number. So if you want to show it on a number line, basically this would be all the x's greater than, or all the numbers greater than 2. So I have to highlight here. 2 is excluded, so that's an hollow circle. So yeah, something like that. And in C, we have upper bound. So it's all the numbers between 2 and 4. Again, the assumption is that it's real numbers, all the rational and irrational numbers included, unless, like in D, there is a limitation or constraints on X, that here they specifically mentioned that they want X to be an integer, right? So it should be from integers, meaning which if I list it, I get nothing but 2, 3, and 4, right? However, in C, if they ask us to name or call 2 members of C, we could say 2, we could say 3.1, right? Because these are all, we could say pi, because pi is 3.14, right? So that also belongs to this set as well. It doesn't have to be a number, it could be a pair of number, like in this case in E, it's actually a point, right? That's the coordinates. And what's the relation between X and Y? It's given here. So basically it's all the coordinates which follow this relation. If you give X to be 1, let's find an arbitrary number. Let's give X to be 1, and Y would be 2 minus 1, which is 1 as well. If you give X to be 2, then we have 4 minus 1, which is 3. So these are 2 members of E. Now, how do we show that an element belongs to a set? So this is the symbol, right? This is the symbol we use, and that means belongs to, or is a member of. So this is a member of E, this is a member of E. However, 0 and 1 is not a member of E, and this is how we show it. Very simple. Same thing here. 5 here is not a member of A either. Okay, and that brings us to the next topic, which is subsets. So if you have all the elements of one set which are shown in another set, so we say that there are subset. For example, let me define a new set F, and its members are 2 and 3. So you can see all the members of F also appear in A, right? We have 2 and 3 here. So I can say F is a subset of A. And how do we show that? So this is the symbol. So F is a subset of A. So I can have another set which only has one element, like G, which has only one element, and also G is a subset of A. However, G is not a subset of F, because you don't see one in F, do you? However, out of all these subsets, we have some of them which are proper subsets. So in order to explain that in more details, let me erase some of this stuff. We don't really need that. And let me have set A only on the board. So I'm going to list a bunch of sets, and you will see that it's the relation to set A. So we have, let me define new sets like B. Let me reduce A to 1, 2, 3. Yeah, that's easier. So let's say A has 3 members, 1, 2, 3, right? And B just like A, and we have C, which has 1 and 2 only, D, which has 1 and 3 only, E, 2 and 3, and then we have F, G, H, respectively. Each one of them, they have only one element. Okay. And lastly, I'm going to define a new set which is called empty set. So empty set is a set which doesn't have anything in it. So there are two ways you can show this. This is a symbol which we can use to show that this is an empty set, or also two curly brackets and nothing between. So it implies the same thing. So these two represent empty sets. Now, empty sets is actually a subset of any other set. Okay. Also, a set which has all the elements as another set, it's considered to be a subset of that set as well. So you can say B is actually a subset of A. You can also say I is a subset of A, right? So the rest, meaning which from C all the way to H, these are also called subsets, but they have a special name. We call them proper subset. Proper subset, and the notation that we use is just this symbol. So for example, F is a proper subset of A. F is a proper subset of C as well, right? And F is a subset of A as well, guys. So proper subset is a subset as well. So basically all of these are subsets of A from B all the way to I. So it's not wrong if you say F is a subset of A, but F is a proper subset as well. So out of which 6 of them are proper subsets. So to understand this better, maybe we can do some examples here. Yeah, so let's go through these two examples. The first one, we're given a set which has 3 members, and we're asked to list all the subsets. So you can start with the set itself and call it, just copy down the set itself, all the members. So that has 3 members. Then we go to the 2 members sets, which is P, Q, and then P and R, and then Q and R. So we're done with the 2 members, then move on to the single members. See, that would be Q, P, and R. So we have one more to go. You can call it I, the empty set. So these are all the subsets, and the proper subsets are basically these ones. Yeah, these are the proper subsets, but everything is a subset of J. And The second question, that's a true or false. That's very straightforward. Algeria and Egypt are, so this is the symbol for subset, right? Are subsets of countries in Africa. That is correct, right? Orange and mango are subsets of fruits. That is correct. 1, 2, 3, 4 is a subset of 1, 2, 3, 4. That is correct as well. 1, 2, 3, 4 is proper subset of 1, 2, 3, 4. That is wrong because I said proper subset only. Yeah, you can see that here as well. So these two, the empty set, right? The empty set and basically the set that contains all the elements of the original set, these two cannot be proper subset. So 1, 2, 3, 4 cannot be a proper subset of 1, 2, 3, 4. On the previous example, same thing. So these two guys right here, the empty set, as well as set B, which contains all the elements of set A, these two cannot be the proper subset of A, right? So having said that, this is wrong. And lastly, 8, 9, 10 are not proper subset of whole numbers, and that is wrong as well because they are proper subset of whole numbers, right? So they should have changed this to this. All right. Okay, which brings us to next topic called Venn diagram, right? So Venn diagram is a very powerful tool, and it's a way that allows us to show sets diagrammatically. For example, set A, which has 4 members, 1, 2, 3, 4. Instead of writing it this way, you can just draw a circle and scatter all those numbers inside these circles and call it set A, right? As simple as that. But sometimes these sets, they overlap, right? They have something in common. If I, let's say, put another set here, such as 3, 5, 6, and if you're asked to draw a set diagram to represent A and B, well, I have to draw another circle which kind of overlap with A, because A and B, they have a common member, and that is 3, right? So this is B, so 3 belongs to both of them, and the rest 5 and 6 belongs only to B. And having said that, to complete this, I have to introduce to you guys universal set and complement set. So what is universal set? Universal set, first of all, the notation is U, capital U, and it depends on the problem itself. So different problems, we have different universal sets. So for any particular problem, it's basically the set which contains all the possible elements for that problem. Okay, for example, if I define U to be all the numbers from 1, all the integers from 1 to 10, including 1 and 10, and I have set A and B here, and if you ask to draw the corresponding Venn diagram for this problem, so I have to draw the universal set to complete my drawing. So usually the universal set, we use a rectangle, and it must cover and it must contain all the other sets inside it. We have all the elements from 1, 2, 3, 4, 5, 6. So what is missing? 7 is missing. I put it outside. 8 is missing. 9 is missing, as well as 10. And this is called universal set. So in this problem, my universal set is all the numbers from 1 to 10, and it could be something else for another problem, right? But it should contain all the elements. Now, what is a complement set? So complement set, for example, take a look at set A, which has 4 members. The complement set for A is the set of elements which are in the universal set, right? But they are not in A. So what are those numbers that appeared in universal set, but you don't see them in A? Those are 5, 6, 7, 8, 9, and 10. So this is complement of A, and this is how we show it A dash, right? Now, a tricky question. What is the supplement of the universal set that's an empty set? And what is the complement of empty set that's universal set, right? So having said that, we can do a little more trickier question, but since we are here already, let's take a look at this region where A and B overlap. So in other words, the element, the 3, right? The member 3. That's the intersection of A and B, right? That's what A and B, they have in common. And the intersection symbol is this. So if you want to show the intersection of A and B, we say that it's 3, right? As simple as that. In contrast, we have the union, which the symbol is like a U, and it contains all the elements in the set. So if you say, what is the union of A and B? So it basically contains all the numbers from 1 to 6, right? According to our problem and by referring to our universal set. Now, this is just an introduction to Venn diagram. The usage of Venn diagram is for more complicated questions, but before we get to the real stuff, maybe you can try and answer this question yourself. Well, I think it's quite straightforward. They're asking, what is U? Well, my universal set here is all the numbers listed from 1 to 8, right? Okay, and what is a complement? You see this symbol? A complement, that would be anything but A. So maybe I can shade it for you guys. Anything outside A that is in the universal set. So anything outside A, that would be a complement, right? And that means 1, 4, 6, 8, if you want to write them in an increasing order. And then they're asking what is A intersection B. So that would be this region that they're sharing in the middle. That would be 2, 2 and 3, right? And A union B. So basically all the members of A and all the members of B together. So we have everything except 6, right? 6 is outside of A and B. So I'm not going to write it down. Now, this is a nice question. Guys, we have intersection of 2 sets, and then after that, you have to apply the complement. So please take care of what's inside the bracket first, and then apply the complement, meaning which find the intersection of A and B first, which is 2 and 3. Okay, so 2 and 3. Can you imagine this region, 2 and 3? Now, what is the complement of 2 and 3? It means everything except 2 and 3, everything that is outside 2 and 3, outside that region, but inside the universal set. And I have shaded that in blue. That means it's 1, 4, 5, 6, 7, 8, right? Now, next one. So this is a good comparison. Take a look at these two. There is no bracket there. So if there is no bracket, the priority is to take care of this complement first. So find the complement of B first, and then find its intersection with A, or see where they overlap. So I'm gonna erase what I have shaded here. Now, what is B complement? B complement is actually anything outside B. So I'm gonna shade it here. So that's the first thing you have to find, since there is no bracket here. Now, what is the intersection of this region, which I have shaded, with A? So the intersection with A is only this region, right? Which is 5 and 7. So the final answer for this question, which looks a bit similar but totally different from the previous one. So the answer is 5 and 7, right? So, and lastly, what is N? When you see the letter N in front of a set, that means write down the number of elements in B. So B has actually 5 members. So the answer would be just 5. You don't need to write, don't put it in a curly brackets, because that would be totally wrong. This indicates a set which has single member, and that member happens to be 5. But here we're looking for the number of elements in B, which is 5. So 5 is totally different from a single set which has 5 as its only member. So let's get to the real questions, which you might come across some of these in paper 4 especially. So this is where the Venn diagram helps us a lot. Let's read the question together. We have a class, 35 students, and 19 of them take Spanish, 18 take French, and 3 take neither of them. All right. So calculate how many take both French and Spanish, just French and just Spanish. So there is something weird about this question, because if you exclude those 3 students which don't take any subject, any French nor Spanish, right? So you're left with 33 students. And if you add up the number of students which take Spanish and French, you end up with 37 of them. So what's going on? Is the question wrong? Because we have 33 students now in this class who are taking either Spanish or French, but when you add those two numbers, you get 37. Well, no, there's nothing wrong with the question. It's actually our logic here is wrong, because who said that these 19 only take Spanish and these 18 only take French? They didn't say anything like that. It means some of these guys here, some of these 19, they are also taking Spanish, and some of these people who take French, they're also taking Spanish. So it's basically the same thing. So we have if you draw the corresponding Venn diagram, there is a region that overlap between Spanish and French. So it's quite difficult if you try to solve this just using algebra without Venn diagrams. Venn diagrams helps us a lot if you draw it. So we have C, I can use the letter, S for Spanish and F for French, and this is my universal set. So the question is, how many of these students take both subjects? So let's consider that to be X, this region right in the middle, and we don't know what X is, right? That's a question mark right there. But if you know this region is X, and if you know the number of students who take French is 18, so basically this circle, whatever is inside it, it should be 18 members. And this region has occupied already X members. So here should be 18 minus X, right? So that's how you start. You put the middle part, or the part which is overlapping, as X. So this should be 18 minus x, and I mean this region, right? And if you add them up together, you see that you get 18 actually. 18 minus x plus x, you get 18, right? And same thing, similarly, here for Spanish is 19 minus x. Okay, and do not forget these three. Three students take neither of these subjects, but they're still, they belong to this class, right? So they should be here. Don't forget these three guys. And now I know the total number of students in this class, which is 35. So if I add everyone inside this rectangle, meaning which 3 plus 19 minus x plus x plus 18 minus x, right? Everything, that should give me 35, right? And if you solve for x, you get that would be 37 plus 3, 40 minus x is 35, and x is 5. So there are 5 students in this class who are taking both subjects, right? And that would be the answer for A, which is, and if you want to use a notation, maybe that would be a professional thing to do. You say S intersect F, that would be, if I put 5, this doesn't make sense, guys. Even if I do this, this doesn't make sense either. We're talking about number of students. So put this in a bracket and put n in front of it. So this is the number of students who are taking both subjects, and the number is 5. You don't need to put it in a curly bracket, because if you do that, you're forming a set. Okay, so please don't do that in the exam. Moving on to the last question, which is a little bit challenging. So if you understand this question, I promise you can answer any questions regarding Venn diagram in real exam. And don't forget, Venn diagrams will be used again in chapter probability. It's very essential for you to grasp and understand how to solve, how to form a Venn diagrams given certain information. Well, without any further ado, let's try to solve this question together. 37 students sat an examination in physics, 48 sat chemistry, and 45 sat biology. And then moving on to, okay, now we have a pair of subjects, physics and chemistry, 15, chemistry and biology, 13, 7 sat for physics and biology. And lastly, so definitely these subjects, they overlap somewhere. So let me draw it. This is, let's say each of these circles represent one specific subject. If this is physics, I'm gonna use the letter P, B for biology, and C for chemistry, right? Let's start with the center. This is the region where actually it belongs to all the students who sat for all 3 subjects, right? This region, and we already know the number for that. It's 5, so I'm gonna write 5 here. And then moving on to the other statement, 7 sat physics and biology. Well, this is physics, this is biology. All right. So you might say this is the region we're looking at, but that is wrong. That's a misconception the student make. They assume this region represents 7, and then they go ahead and say, okay, this region, the remaining one should be so basically 7 minus 5, which is 2, and they put 2 here. And they're pretty confident that it's the correct answer, because they said, look, this region represents biology and physics, which is not wrong in a sense. And they say they should be 7 of them, right? 2 and 5, 7. But that is wrong, because they don't consider that this region at the bottom, there are some students who are taking chemistry. So we can say the corresponding region for these 7 students is this whole region. As a matter of fact, it's only this part. So I'm going to shade it here. Yeah, 7 students should fall in this region. So the region that I just shaded is only those students who are taking physics and biology. And it's very clear that this region, because biology and physics, they overlap on this region, right? So you have to exclude the chemistry. So 7, without any change, you just put 7 there. That's it, right? So moving on to the next information, we have 13 SAT chemistry. And so similarly, same logic, I'm going to use the same logic, and biology and chemistry. So this region is 13, not 13 minus 5, okay? And 15 is here, right? 15 students SAT physics and chemistry. Now the bigger ones, 45 SAT biology. So this is the circle for biology. All you have to do is just to grab your calculator and say 45 minus these 3 numbers. So basically 45 minus 25. So I'm left with 20 here, right? And then 48 SAT for chemistry. This is chemistry. Okay, 48 minus all these numbers, which is basically 13 and 15, that is 18, with 15, that is 33. So 48 minus 33, which is 15, if I'm not mistaken. And moving on to the last piece of information, 37 students sat an examination in physics. So 37 minus these 3 numbers, and that gives me 10, right? Right, that's a Venn diagram right there. But I need to put all of them in a rectangle. I forgot about that. So of course, whenever you draw a Venn diagram, guys, you need a universal set, right? Which in this case, there is no number outside. So we have 0 number of students who are taking either one of these subjects. So no need to put any number outside. Okay, so moving on to the last part. The last part is very easy. They're just asking for the number of the union of all these 3 subjects. So what you have to do is add all the numbers that you have. So this is equal to 10 plus 7 plus 20 plus 5 plus 15 plus 13 plus 15 again, which I believe should be 30, 50, 70, 85. Yeah, that's the final answer. Don't forget that's the N, the number of students who are taking physics, biology, and chemistry. So thank you for watching this video. Don't forget to watch the next video, the topicalized past year paper question for set and Venn diagrams. Thank you. Have a nice day and stay safe.